So welcome back again. The time is 8:23 p.m. I have already prepared the lecture number 1, Introduction of Thermodynamics. We will continue this lecture in the same segment, Introduction. And now you are watching this video on my YouTube platform, Govind Chemistry. And this side, your chemistry mentor, Govind Agnihotri, or you can say Govind Sir. So here, till the last lecture, we finished with extensive and intensive property. After that, we are going to discuss about state variable state variables, or you can say state function, state functions, or state parameter. Okay, so what are these things? See children, one thing, condition, or you can say condition or state of system defined by variable. Now it's confusing, no need to confuse what I said. Condition or state of any system defined by variables, and these variables are called state parameter or state function. Now children, what is variable? Suppose, see, one gas is given. In that case, pressure 1 atm, let's assuming only, temperature 27 degrees Celsius, and volume is 300 ml. So these are the function: pressure, temperature and volume. These function decided the condition of gas. If you want to change the state of gas, what you want? State change. Then you have to change the values. What you have to do? If you want to change the state of gas, then you have to change the variables. Which variable? Pressure you have to change, temperature you have to change, volume. So if these values will be changed, then your system or condition of system will be changed. Okay, what I written? Condition or state defined by variables. These variables are called state parameter or state function. So here I explain the gaseous state defined by pressure, temperature, volume. If you want to change the state, then you have to change these values. Got it? So I am removing this actually, because it's not required now. See, so system, what are the variables? Which are the variables we have to use here? So there are so many variables like pressure, temperature, volume, number of moles, enthalpy, denoted by capital H, entropy, capital S, sorry, internal energy, denoted by capital E or somewhere capital U, gives free energy. Okay, so these are the state variable. One more thing, state variable or state function, they only depends only depends only initial and final condition, or you can say final state. So state variable, state function, they depends only initial and final condition. How, sir? Yes, exactly, your question is valid. See, one graph is given. This graph is pressure versus volume. In this graph, here, here, these are the 2 points. Okay, this is path, this one is path 1 and this is path 2, and these are the condition. So see children, what I want to explain you here, if you want to find out delta P, so you can easily find out how. P final minus P initial, delta V, so V final minus V initial. Yes or no? Okay, so whatever path they are following during the change, no matter. State function, state variables, they are only depends upon the initial and final condition. Whatever path they are following, no matter. Here if we are talking about heat and work, so these are not state function, they are path function. What they are? They are path function. Why? Because path 1 is different, path 2 is different, then different work will be obtained. Once again I am saying, state variable, these are the things which depends upon the initial and final condition only, but heat and work, they are path function, they depends upon the path followed by the system. So here path 1 followed different route and path 2 is following different route. So heat and work depends upon the path followed by the system. Okay, clear? Yes. So this is the condition. So children, now here one important part, here we are talking cyclic process. Although when we are discuss the different processes, that time also I will tell you. Cyclic means here same state, variable change, variables change. No, 1 minute, this is not. So in the cyclic process, children, what happened? Again, I am telling you the graph. This is the graph between pressure versus volume. From here started then here, then here, then here, this, this, this. So in the cyclic process, children, delta P 0, delta E 0 means internal energy, delta S 0, delta T 0, delta U 0. See what happened? You started from here, this point. Once again, I am telling you, and again return back on the same path. What I said, state function depends upon initial and final condition. Initial and final condition. So in the cyclic process, what happened? You started from here and again came back here. Then no change. Huh? Then no change. But if you are talking about delta Q here, so Q is heat is path function, that is not equal to 0, because it is what it is, it will be path function, it is not state function. Got it? So in any cyclic process, state will be same, variable will be changed, and all the values in any cyclic process, these all values will be 0. So here I am writing, in any cyclic process, change in state function or variable will be 0. Okay, change in state function or variable, it will be 0 in any cyclic process. Okay, so that's it. Now the next topic, types of thermodynamics process. That introduction of thermodynamics may be 40 to 50 minutes, but you have to be patience. So first process is isothermal process. What is isothermal process, children? Iso means same, thermal means temperature. Okay, so here temperature same means constant temperature. In isothermal process, temperature will be constant. That means delta T, change in temperature, is 0. One note I am telling you, it's very important. If delta T is 0, we are talking about for ideal gas. Which gas? Ideal gas. If delta T is equal to 0, then delta E also will be 0. Why? You know, E is equal to kinetic energy, and kinetic energy is directly proportional to temperature. So if temperature is 0, then delta E will be 0 for ideal gas. Okay, so it's an important part. Here, constant temperature, which rule we will apply? Boyle's law. Remember, what is Boyle's law? at constant temperature, if T is equal to constant, then pressure is inversely proportional to the volume, and the graph is, what is the graph? Pressure versus volume. It's a rectangular hyperbola. Number 2, isobaric process. What is isobaric process? Again, constant pressure. Constant pressure, that means change in pressure will be zero. Change in pressure will be zero. You know, children, all the chemical reactions generally 90% cases they are isobaric. Pressure is constant. So what is the graph in if pressure is constant, children? See, pressure, volume. So what will be the graph? Pressure constant, this will be the graph. Number 3, isochoric or choric, but it's called isochoric, huh? Isochoric process, constant volume, that means delta V, change in volume is zero. Graph here only I am telling you, constant volume, this will be the graph. This is for isochoric, and this is for isobaric. Confirm? Number 4, adiabatic. Adiabatic process, delta Q is zero. Change in heat, that means no heat exchange. So what is the graph, children? No heat exchange. See, in this graph, graph number 1, graph number 2. So in graph number 1, in adiabatic process, it is having more slope. This black line, it is adiabatic. Why I am telling you these graph? Because sometimes they will give graph between adiabatic and this is your isothermal, and they will ask which is isothermal and which is adiabatic. So in adiabatic, more slope, isothermal, less slope. Here, slope more. And number 5, cyclic process. So in the last part, we have discussed about the cyclic process. So that's it about the thermodynamics process. I hope it is clear. One more thing is pending, and this introduction will be finished. So check it. What is that? Thermodynamics process. Sir, yes, you told me 5 types: isothermal, isobaric, isochoric, adiabatic, cyclic. Yes, I told you, but two kinds of process. All the thermodynamics process divided into two kinds. What two kind? See, first is reversible process, and second, irreversible process. Sir, you are confusing so much. Yes, it's a confusion, but no need to worry. I will clear your confusion. In that case, what is reversible, children? Give me 2 minutes. Think about it. Okay? Nothing I am going to write. You have to think about it. In reversible process, generally, children, reversible means what? Which can reverse. What new you are telling me, sir? According to the word, it is clear. Yes, but reversible means you can reverse the process. Irreversible means you cannot reverse. It is just like suppose any process is completing in more time. If process is completing in more time, then you have more time to reverse the process. Yes or no? When the process is completing in more time, suppose any process is completing in 1 year, so you have 365 days to reverse the process. But any process which is completing within the second or very less time, then you have less time to reverse the process. Yes or no? See what I am saying. If process is completing in more time, infinite time, then there are more chance to reverse the process. So here you can write which process which occur in this occurs in infinite time, or you can say in small steps. It is completing in a small step. That means infinite time to finish. Infinite time to finish. Children, it's a matter of understanding. Any process which is taking more time to finish, then you have more time to reverse the process. Infinite time to finish. And here they completed at once. Finite time. So these are the slow process, and this is the fast process. Number 3, each step is in equilibrium. Each step is in equilibrium with previous step, because it is completing step by taking long time. So each step is in equilibrium with previous step. That means equilibrium exists always. In the slow step, they are always in equilibrium. Here what happened? Because this process is completing in finite time, then initially and finally equilibrium is there. Equilibrium, where you will got equilibrium? Initially and finally. Initial step and final step will be in equilibrium, not in between. Yes, sir, you are confusing so much. Don't no need to confuse. These are the points. Note it down carefully. And now I'm going to erase these points and I will give you example. Okay. So these are the theoretical point of view. So here the thing is, check it properly. It's already 16 minutes over, and I will take 4 more minutes. So 20-minute video will be completed. Check it. See what happened here. Suppose this is the vessel. Today in both video train is available, huh? Here gas is filled, okay, and then I applied one piston here. In this piston I am putting small weights, very small weight. Small weight I put it, and here this is the pressure and this is the pressure of gas. System is in equilibrium. Perfect. Then what happened, children? If you removed one weight, if you remove one weight, then what happened? They are very small. Then equilibrium disturbed. That means gas will expand. So what happened if gas will expand? Here, but that expansion is very less. That expansion is very less because that weight is very small. Okay. So small expansion is there. So here pressure will be reduced. That means suppose pressure reduced by dP, small pressure, and after that now the pressure is P minus dP. Okay, and again equilibrium established. So each step is in equilibrium with previous one. Suppose again you will remove one, then again small change in pressure, and again small expansion, and again equilibrium will be established. But if you removed, suppose here piston, small weight, and equilibrium, pressure, okay. So if you removed all the weight, all weight remove, so suddenly expansion will take place. Yes or no? Suddenly expansion will take place, and that is delta P. Here P minus delta P. Sudden expanded, and again this is the final, and this will be in equilibrium, and here it is initial equilibrium. So that is the explanation, children, for this. I cannot explain more. This is enough. So this is all about the introduction of thermodynamics. In the next lecture we will discuss about the heat. So thank you. Please watch the video and subscribe the channel.